Just imagine if right now, this very second, we launched our fastest machine ever built in any direction, as fast as humanity has ever managed to send anything. How long would it take to cover just 1 light year? The answer is so shocking that most people go quiet when they hear it. And once I tell you that number, you'll also realize that the picture we carry in our heads about space is completely wrong. We think distance is the problem. But the real problem is something else entirely. And that problem is so massive that our entire lifetime, our entire generation, might pass away just trying to solve it. So let's start. First, let's understand just how big a light year actually is. A light year is the distance light travels in 1 year. Write out the number and it comes to 9.4 trillion kilometers. That number is so large that if you tried to measure this distance on Earth, it would take your entire life just counting. Now let's bring this number into the real world. Voyager 1, the fastest, farthest object humanity has ever built. It's been flying since 1977, meaning almost 50 years now, non-stop. Its speed? Around 17 kilometers per second. That speed is so extreme that if it passed near Earth, it would cover in 1 second the distance a bullet train takes hours to cover. But despite this incredible speed, today Voyager 1 is only about 165 astronomical units from the Sun, roughly 25 billion kilometers. If we measure that distance in terms of light travel time, Voyager is currently just 23 hours away from us. Only 23 hours in terms of light. It won't be until 2029 that it finally crosses a full light day. The distance light travels in just 24 hours. Think about that. A machine that hasn't stopped flying for 50 years still hasn't covered even 1 day's worth of light's distance. Now a question probably comes to your mind here too. If Voyager has traveled this far and yet made so little progress, then where does our solar system actually end? Most people think it's at Pluto. That's completely wrong. The Sun's gravitational and magnetic influence, known as the heliosphere, extends roughly 120 astronomical units. Beyond that begins the Oort cloud, a region of icy objects that may stretch for a full light year. Here's where the first big problem comes into view, one I want to show you. Problem number 1. Speed alone isn't enough. The real challenge is the in-between itself. People think that if we just build a faster ship, the problem is solved. But the truth is, the space between stars is so empty that an average cubic meter doesn't even contain one whole atom. Imagine flying for years and looking out the window to see the exact same view. No planet in sight, no light, no landmark. Just stars, shifting so slowly that even after decades, the difference is barely noticeable. And this isn't just a matter of years, while we're still within our own solar system. The moment we truly enter interstellar space, we're talking about centuries. Entire generations could be born and die during this journey, and the view outside would still remain almost exactly the same. Let's understand this problem through 3 real-world examples. Voyager 1, at 17 kilometers per second, would take roughly 17,000 years to cover a single light year. Just let that number sink in. 17,000 years ago, humans were painting the first cave paintings. That much time has passed since then, until today. And that's just 1 light year. Now, the Parker Solar Probe, which reaches record-breaking speeds of around 700 kilometers per second during its close passes by the Sun. Even at this speed, covering a light year would take roughly 430 years. And then there's Breakthrough Starshot, still just an idea, not yet reality. The concept involves tiny probes accelerated by lasers to reach 20% of the speed of light. At that speed, a light year could be covered in about 5 years. Seeing these numbers, it feels like we've found a solution, right? But there's a catch here that very few people understand, and it leads us straight into the second big problem. Problem number 2. No matter how much you increase speed, the human body and technology have limits we haven't yet figured out how to overcome. The probes we're talking about at 20% light speed weigh in grams, postage stamp sized, not a spacecraft capable of carrying humans. The moment you factor in mass, life support, and the need to slow back down, the realistic speed immediately drops to a mere fraction of that number. Then comes the energy problem. Getting even a crude capsule to a fraction of light speed is many times beyond the capability of our current propulsion technology. Chemical rockets are completely inadequate for this task. Ion thrusters, though highly efficient, take an extremely long time to build up any significant speed. Now pause and think. If you were actually on board that spacecraft, would you take this risk? Because the next problem isn't just about technology anymore. It's about your own life. Radiation. In interstellar space, there's no planetary magnetic field to protect you. Cosmic radiation would bombard biological tissue for years, and there's still no practical shielding that can reliably block it over such long periods. And dust. Sounds like a small thing, but at extremely high speeds, even a tiny speck of dust carries as much impact energy as a projectile. One small particle, and the entire spacecraft is at risk. And even if the spacecraft survives all of this, one final problem remains: communication. Even from the edge of the solar system, a radio signal takes hours to reach Earth. At a distance of 1 light-year, a single message would take at least a year to arrive back. The concept of conversation, as we know it, completely breaks down there. So holding both of these problems together, the first problem is that the space in between is so empty and so long that time itself loses its meaning. The second problem is that no matter how fast we go, our bodies, our technology, and the very laws of physics hold us back. But now comes the most interesting part: the solution. If you were actually on that spacecraft, what would you actually feel? Without acceleration, movement through space feels exactly like standing still. No jolt, no sound, just an extremely slow shift of the stars, barely noticeable over the course of years. The constellations would remain almost unchanged for most of the journey. Only when you truly approach your destination would that star begin to brighten, eventually outshining all the others. And the sun, our own sun, would slowly grow dimmer. It wouldn't vanish suddenly, but fade gradually over months and years, eventually becoming just another point in the sky, barely distinguishable from the rest of the stars. Now let's put this in perspective. Proxima Centauri, our nearest star, is 4.2 light-years away. That means even if you cover a full light-year, you haven't even completed a quarter of the way to Proxima Centauri. And Proxima Centauri is actually the lucky case. Most stars we see in the night sky are 10, 50, or even 100 light-years away. A single light-year doesn't get you anywhere close to a real destination. And here's the most shocking part: that entire light-year might not even take you outside our own solar system. Because the outer edge of the Oort cloud may itself extend for a light-year, some estimates even say up to 2 light-years. So theoretically, you could travel a full light-year and technically still be within our own sun's sphere of influence. This completely shifts your perspective. What feels like a massive, monumental distance to us is, on a cosmic scale, just the first step. The Milky Way is over 100,000 light-years in diameter. And even in our own corner of it, the Orion Arm, there are thousands of stars far more distant than a single light-year could ever cover. In this context, a light-year is practically nothing. On a galactic scale, it carries no weight at all. A single light-year pushes our current technology, our energy, our time, and the limits of human endurance to their absolute edge. And yet, compared to the rest of the universe, that very distance is nothing at all. Just recall these numbers once more. Voyager 1 would take roughly 17,000 years. Breakthrough Starshot, if it ever works, could cover a light-year in just 5 years, but only for something the size of a postage stamp, not for a human being. The entire history of space exploration, from the very first probe to the boldest dreams of today, actually fits somewhere between these two extremes. And even at the upper limit, 20% of light speed after covering 1 light-year, you would technically still be within the influence of our own sun. Everyone knows the universe is vast. But what's truly astonishing is that even the very first, smallest step into that vastness is still, today, beyond our reach. So now tell me, If humans ever set out on this journey, would you take the risk of being on that spacecraft? Or would you rather stay on Earth and simply watch this empty, silent yet astonishing universe from here? Let me know your answer in the comments. I really want to read what you think about this. And if this video made you think, hit subscribe so you don't miss it next time we uncover another secret of the universe.